Hey everybody, this is Mr. Beckstrom, and today we're going to look at section 3-4. This is on circles, and I want to start with a couple of different parts of the circle, and then we're going to talk about the formula for the area of the circle. So first of all, if we look at the distance halfway across the circle that goes through the center, so that would be from the center to any point on the circle itself, that is the radius, or little r. Now if we talk about the distance from one side of the circle to the other side going through the center, that is the diameter. And the diameter is 2 times the radius. So if we're given the radius and we want to get a diameter, we would just multiply the radius by 2. And if we were given a diameter and needed the radius, we would just divide the diameter by 2. The circumference of a circle, denoted usually by big C, is the distance around the circle. It's the distance around the circle, and we can find that by taking the diameter and multiplying it by pi, or 2 times the radius and multiplying it by pi, since the diameter is equal to 2 times the radius. And then with the area of the circle, we have that familiar formula pi r squared, where first we take the radius and square it, and then we multiply it by pi. Or if you want to just use the diameter and not convert the diameter to a radius, we can do pi times the diameter squared divided by 4. That'll give you the same thing. And if we just want to get an approximation, that means a value that's pretty close, we can use this formula here with the diameter. So 0.7854 times the diameter squared. So let's go ahead and take a look at a couple of examples here. Alright, so let's go ahead and try to find the area of just this ring around here. So there's nothing in the middle. The distance from the center to the inside ring is 18 centimeters, and the distance from the inside ring to the outside ring is 2 centimeters. So see if you can use these formulas and a little bit of logic to see if you can come up with the area of just the ring. Go ahead, pause it, give it a try, and then we'll go through the solution together. Alright, well, if we were to first find the area of the larger circle, go ahead and make sure I am on. There we go. So if we were to first find the area of the larger circle there, and then we were to find the area of the inside smaller circle, we could just take the area of the larger circle, subtract out this area of the smaller circle, and all we're going to be left with is the ring, right? So if we take the area of the larger circle, that's everything inside this larger circle, but then we subtract the area of the smaller circle, that means that we are not going to be adding or using any area of that smaller circle, and that was not a good enough circle for it to recognize it. So let me try it again. There we go. And then we were to cut out this circle, which I just put inside here. We're only going to be left with the area of the ring. So that's what we're going to try to do here. All right, so what do we need to know? Well, for doing the area, I either know the radius or the diameter. They already give me the radius of the small circle, so that is just going to be 18. And then if I want to try to find the area of the larger circle, that's going to be that 18 plus 2, which is 20. So we want the area of the larger circle, so I'm going to put a little L there, and then we're going to subtract the area of the smaller circle, and I'll denote that with an S there, and that will give us the area of the ring. So the area of the larger circle, well, that has a radius of 20, so that's going to be pi times 20 squared. Let me take that off here. And that's going to give us, 20 squared is 400, so that's going to give us 400 pi. And we can just leave it in terms of pi for now. And the smaller circle, oops, so that equals there. The smaller circle, we call that one a little s. Well, that's going to be pi times 18 squared. I think that one's 386, but I am not sure. So let me go up here and taking a second here. 18 squared. No, 324. 324. All right. So that is going to be 324 pi. Now, remember, we're going to take the larger one, subtract the smaller one. So we're going to take 400 pi minus 324 pi. And we're going to get, looks like 76 pi. So our final answer here would be 76 pi. And if we wanted to get an approximation of that, we go to our calculator and just do 76 times pi. And we'll get about 238.76. So that would be our approximate area there. All right, let's take a look at another example here. All right, so this one looks like it's going to be kind of a hard one here. So we have this weird shape. It kind of looks like a trapezoid with a half of a circle missing. So just as a refresher, the area of the trapezoid is, I'll do area, I'll put a little t there for trapezoid, is equal to 1/2 times the two bases. That's the two sides that are parallel to each other. So the average of the two sides that are parallel to each other times the height. So go ahead, see if you can solve this one. Pause the video, and when you're ready, go ahead, unpause it, and we'll go through the solution. All right, so it looks like if we take the area of that trapezoid and we subtract half of the area of the circle, I'll put a little c there for circle, that should give us the area of this figure right here, right? Because we're taking a trapezoid and then we don't want a half a circle here, so we're going to subtract half of the area of the circle, and there we go. So let's first figure out the area of the trapezoid. So the area of the trapezoid is going to be equal to 1/2 times the two sides that are parallel to each other. So we'll use the top and the bottom. So 46 plus, and this is going to be, so we're taking this length plus that length plus that length plus that length. And if I pull up my calculator, that is going to be 51 plus 32. That goes from here to the center, plus another 32. That goes from the center to here, plus 51. And that's going to give us 166. So plus 166. And let's see what that equals. That is going to be, 46 plus 166. And then we're going to multiply that by 1/2 or divide it by 2. That's the same thing. And that gives us 106. 106. So that would be our answer for that. But remember, that's too much, right? Because we don't want the half circle in there. So how do we get rid of that half circle? Well, let's find the area of the circle, and then we'll take half of that. So the area of the circle is pi times the radius, 32, squared. This is weird, huh? This is, that might be to scale there. And that's going to give us 32 squared times pi. Let's see what 32 squared is. Go on the calculator. 32 squared. That gives me 1,024 pi. So 1,024 pi. All right. Now half of that, half of the circle is going to be half of this, so if you divide that by 2, you're going to get 512 pi. 512 pi. And now we're going to take the 106. Hold on one second here. Something does not seem right. I did totally leave something out here, didn't I? Hopefully you caught that. But I forgot to multiply by the height right here. So that is times the height, which is 91. So that is a much different problem, isn't it? So I knew something didn't seem right. So 46 plus 166. That's the 212. And then we're going to take half of that divided by 2. And then we're going to multiply that by the 91 times the 91. So that's 9646. So this is actually equal to 9646. All right, so to find the whole thing, we're going to take the 9646, and subtract the 512 pi, and I'll use my calculator. So we're going to get that minus 512, and then we can put the pi in there just like that. And we're going to get approximately 8,037.5. So this is approximately equal to 8,037.5. All right, well, that's all I had for you on this one. So if you have any questions, let me know, and I hope you all have a great rest of your week. Thanks.